do I mean by in memory? Let's take a look at where your data file is. Where is your data file can select name from $, data file. So these, at least for my workstation, this is where you can find these files. Now, if I say select average from scott.imp, the data is physically in the user table space. Now, as you know that these process, when they read from the disk, okay, so in this example, my scott.imp is probably coming from these database files. Now the server process receives my query, and it actually does something called a hashing process to turn my query into a SQL ID. Now that SQL ID is then looked up against the shared SQL area to see if this query has shown up before. If this query has never been executed before, then the server parses it and then forwards the query to the query optimizer, and the optimizer comes back with a plan, and the server process executed according to the plan. So the plan tells the server process how to read blocks from disk into the buffer cache. And then in my case, I'm doing an average of the salary. So after these blocks are copied into the buffer cache, the server process then goes through this buffer, and while going through the buffer, start calculating the average salary. Now, at the end of that process of calculating is the server process will come up with the answer. The answer is whatever the number is, and it's then delivered back to the user process. Now, this design of reading from disk into memory is because reading from memory is so much faster than asking the hard disk needle to go to a specific location. Does that make sense?
Can I ask a quick question?
Please, please, please do.
So the you mentioned the plan. So basically, the plan tells the server process how it's gonna actually access the data from the database. The plan is highly dependent on whether disk or SSD is used. Is that going down to that level?
The plan, it might be, but usually the big influence of the optimizer is based on the object statistics. Okay, so I want to do one quick thing before I get back to the plan part. Okay.
Sure.
No problem. No problem. I will get right back there. So here's a table space, so we can look at how Oracle stores data. So let's say we have a user table space has 10 megabytes worth of data, right? No problem. And let's show table space content. This is one of those tools that's graphical, so it's easy to grasp what's going on. So remember that user data file here, user.dbf. Now, when you take a tool to start reading it to see what's in that file, you'll see that the files contains extents. Extents belongs to, well, stuff. So you'll see that this is an extent map. Okay. Now you can imagine that's what your file looks like. A file has header, and then there are various extent. So notice I have one table for me, for example, I have an OE line item table that has the extent located here, located here, located here. So in other words, when you create a table, only an initial extent is allocated. When you insert enough data, another free extent may be allocated and it becomes your next extent. So notice how far these things can potentially be. So if I look at PK department, it's here. Scott emp is currently right here. Now if I insert a bunch of scott.emp, well, it's raining cats and dog here. Insert into scott.emp by
by the way, those
yes, go ahead.
DBF files that you're showing there, they're actually the tables themselves, right?
Correct. Correct. Each table has to occupy some space somewhere. So we call this extent. Okay. So scott.emp currently has 64 KB of space allocated, and it occupies one extent. Okay. Now, where am I? Select. Okay, you know what? I forgot what is scott.emp have. Employee number. Fair enough. So I'm going to insert into scott.emp by selecting emp number plus 1 plus 1000. Name, job, mgr, hire date, cell, com. Okay. Okay, I'm just going to see if this will actually make it over 64 KB. 64 KB happens to be quite a bit of space, so it might not. Okay, so let's see if we can rerun this. Now let's focus just on table segments. By the way, segment is just, okay, it hasn't grown yet, but if it grows further beyond 64 KB, if it grows beyond 64 KB, it would then allocate another space. As you can see that the bigger the data file, the messier the data file is. Because when you create a table, Oracle cannot predict whether you will put in 100 rows or 100,000 rows, right? We have no way of actually figuring that out. So what Oracle is doing is I will give you one extent. We call that initial extent. And the initial extent is 64 KB, 8 blocks. It's initially 8 blocks of table space block size. Now, because my table space is 8K block size, 8 blocks equals 64 KB. Okay. Now, you'll find that if I show you the example table space, okay, it has more things in it. Okay. And you'll see that the bigger the extent becomes. So the bigger the table it becomes, the more space each extent will allocate. So to do that, it's much easier to see visually. So for a large table like SH customers, there are 27 extents. So that means after it fill up the first extent, it allocate the second, the third. It has allocated 27 extent to this sh.customers. And these 27 is actually clickable. So if you click on the 27, it's going to show you. In fact, even before it comes back, I would like to zoom in. You'll notice the first few extents are smaller in size. You notice these are smaller in size compared to these ones. So the extent gets bigger, the bigger the object becomes. So that's a variable extent size. And you'll see the first 16 allocations are all 8 blocks each. Now, when you grow past that size, Oracle goes, well, it's getting bigger and it's probably going to get bigger. So every extent allocation is now 128 blocks. And it goes up and up. There's a built-in rules of how many blocks as it grows bigger. Okay, and what you will notice that these blocks are literally all over the place in your data files. Now, are we okay so far with the data files and why it has to go into memory? Because disk with a needle, like a record player, is very slow. But once it's reading into memory, now I can use it to say, what's the average salary? What's the minimum salary, right? Now I can just calculate off of those buffer cache without having to perform a disk I/O. So here,
Okay.
I hope that makes sense. So here, if I do a min and I do a max, okay. So notice there's no physical read anymore. The goal here is to minimize your physical read. Okay. There is a consistent get. When you see consistent get, it means you are reading from the buffer for the consistent version of the data. And that's just basically what that means. So notice once those blocks has came out of disk into memory, I don't have to do any physical reads. And however, if I do select count, I want to see how many customers do I have. Remember, that's a big table, right? Okay. So notice I have to do 5 physical reads. Okay, because those blocks are not in memory, so I have to go to the disk in order to get those blocks into memory, and then I can do my calculation. And notice subsequent, I ran the same exact query again. Notice how this time it doesn't have a physical read again because it's now in a buffer cache. Does that make sense? Cool. And again, this type of design is to minimize your physical I/O. It's one of the four things, right? One of the four pillars. So trying to minimize the I/O. Okay. Now, yes.
Table space. So table space is the tables, and these table spaces. Let's say you got 5 tables slash table spaces. They share the same extent.
No.
They could be found in the same extent, or they have their own. Each table would have their own extent.
Very good question. Okay. Usually, when you create a table, simple one, you can specify table space. So this will create this table in the tablespace users. This is what we call a simple table. Now, in fact, this table has no special storage capabilities. Now, Oracle actually uses a different word. Oracle actually used the word cluster table. Oh, by the way, before I move on, after I create this table, if I insert a record, okay, now this table is going to allocate an extent. These kind of simple table has dedicated extent. Okay, and let me draw a quick big circle for you. Now that's a table space. An extent can never outgrow the size of a table space. An extent. Notice my keyword here. Extent must be wholly, I don't even know if that's the right word, wholly owned or wholly stored within a single table space. Okay. Now, besides extent, there are two other kinds of things that Oracle has terminology for. The first one is called partition. The other one is called cluster. Now, both of those are exceptions to this rule. The cluster allows a single data block to accommodate records from two tables. So a cluster essentially is a specialized type of extent used to accommodate two or more tables that has a shared key. So for example, your customer and their orders, you always retrieve them one after another. So you really don't want to store your customer here while your customer orders here, because now you're making your needle go to two different places just to find out what did Bob buy. So you can create a cluster segment. Okay. You can create a cluster that can accommodate more than a single table. Now, partition is in the event that your table is really big. Now, folks, it's really difficult for server to go through. Let's say you have 5 hard disks. Now, you can put 5 GB on a single disk, or 5 times 1 GB. across 5. I think everyone with a common uh, you know knowledge about these disks would say, hey, it makes more sense to spread the 1 GB across 5 physical disks, so at least each section is only 1 GB in size. So if I'm searching for something and I know it's within that partition, I don't have to look for through many records. Okay, so partition allows you to take one segment. Ah, okay. Partition is when a segment spans across table space. Okay. I think I had a question coming in. What's the difference between partition segments? Now, that's where Oracle terminology comes in. Okay. Segment equal things that consumes space. Index, table, lob, uh, materialized views. Now, these are things that actually consumes space within your data files. So we call them segments. Okay, so you'll find index segment, a table segment. A segment is made up by one or more extent. Okay. Now, a segment can be created for a single table or created for 2 or more tables to share. Now we call that cluster. We call that cluster. Segment a table or index that that is big, 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 divided into partitions. So in other words, one table has many segments or many partitions. It's very important to recognize once a table is partitioned, it's no longer called segment. It's now called partition. There's just to disambiguate between the table that's made of a single segment. Okay. And a segment must be wholly stored within tablespace. Okay. Cool. Linked together. Okay. Does that clarify this somewhat or just made things somewhat worse? I hope not.
Yes.
Cool. No problem. Awesome. Okay. So let's clarify these syntax things that we have. Okay, now you can quickly find these examples. Just type in Oracle cluster example, and I'm sure there will be some really quick, straight to the point examples. All usually at the end of this document. Okay, so first you create a cluster. That's called a cluster. Notice this cluster is a standalone object. The cluster is only created with a column in mind. It will allocate 100K initially, and when that 100K is used up, it will then allocate another 50K. Then, before you can put tables onto that cluster, you need to create an index. And then, as you create table, you tell that table to use the cluster for its storage. So the end result is these two tables will share the same physical storage place. So we call that a cluster. And we also have Oracle partitions. Now, by partitioning a table, you can take okay, so notice if you're looking for all the orders, if you don't partition it, you have a lot of record to go through. Now, if you partition them by month and you say, I want all the orders in February 15th, it's very easy to pick that up. And you don't have to look beyond this part. It's only 1/3 of the size that you have to search across. Okay, so partition allows you to chop up a table. Okay, you notice that this is actually a pretty comprehensive thing you can do. Okay, and Oracle partitioning is one of the most flexible feature across all products that I came across. Okay, so these are things you can do with a partition, but it's not the big point there. Okay, so let's take a moment to talk about execution plans. So I'm looking at Google Map. There are two people here, two actors. First actor is me. The other actor is Google Map. So keep that in mind. In Oracle terminology, me is the server process. It's not, by the way, the word server is not a description. It's the official name for that process. Every process has a name. Okay, so you have redo log writer, LG writer, checkpoint. Those are all process names, right? The server process is the actual process that handles your request. So me is the server process. The Google Map is the query optimizer. So I want to go from 11367 to JFK. Actually, you know what? Okay, and I want to get directions. Cool. All right, so I'm getting directions. It's fairly easy, right? I have, if you're driving the car, go this way. If you're walking, do that. If you're bicycling, do that. If you must take a plane, I guess there is no must take a plane option here. Okay. Now, everything I am showing you here is a plan because I am still sitting on my chair talking on the session. I did not move or actually do anything. This is only a plan. Now, this is a very simple 2 points on the map. Now, as I expand the range, which is synonymous to the complexity of your query, you can select from a single table, or you can select from 5 table join. You can select from 10 table joins. Okay. Someone mentioned data layers. Okay. Now, the reason that most of the data layer exists is to handle different programming paradigms. Okay. For example, Java is object-oriented. It wants to deal with arrays, collections, object that relates to one another, right? So we have things like and hibernate. We have things like various frameworks. Hibernate frameworks, and some other object relational mapping. Now, what happens is those type of layers generates the query that hits the database. Now, it's convenient from a Java's perspective. I want a collection of all my customers so I can find out who is my favorite. Now, that kind of question may become, go to the database, pull 10 million customer back so I can create 10 million instances of Java object so I can use Java's for loop in order to find out which one is my favorite. Okay, so I guess the important thing is to say is these queries can quickly become very, very complex when you start to introduce relationships. So when you say in a Java land, I say, I want all the customers whose order is more than $10,000 and has placed more than 6 orders in the last year. So those kind of things is very expressive in the Java world. Okay, you have things like extension methods, you have lambda expressions, you can throw all those things in it and it just becomes a humongous query on the server side. So the more complex you can compare to Google Map. Okay, so notice once I increase the distance, I have choices. I mean, I really have choices. Bus, I have route 1, route 2. So in other words, I have different ways to use bus. Now, as a human being, I can take my time and evaluate all my options. In Oracle database, we're not going to expect someone to make the decision. So the optimizer essentially within split seconds has to look at through all the options and say, out of all the available options, this is what I think is the fastest. Boom. And the optimizer then give the server process, here is your plan. Up to this point, the server process hasn't done anything. The server process just sits in the chair like I do and waiting for a plan to be presented. And as soon as a plan is available, server doesn't ask questions. The server doesn't go back to the optimizer and go, why do you do this? That's not the server's concern. The server will just start to follow the directions. No question asked. It's going to follow it step by step. And that plan is going to allow the server process to return an answer. Now, in our analogy, it will allow the server to get to the airport. That's the execution phase of your query process. Any questions so far? Any questions so far, folks? Folks, you're still there, right? Testing. Checking.
Yep. Yep.
Okay. All right. So if you're still there, thank you. I got a question for you. The question I have for is that how does Google know that I will spend 3 minutes from here to there and 30 minutes from here to there and 3 minutes here to there? How does it know that stuff? How does it come up with 13 minutes? It must be black magic.
Distance,
Huh? Go ahead.
distance, traffic, conditions. I mean,
Very good. Cool.
stoplights, number of them there.
Very good.
The speed limit, I guess.
Speed limit. This day and age, there's no escape. You can mute your phone, and there's like 5 other things that will ring at the same time as long as you're online. When I retire, I'm going to Brazil. Anyone from Brazil today? Just out of curiosity. No one? Yeah, you see, the M.Dot class usually has some folks from Brazil. You know, folks, I just learned Brazil is like the fourth largest country in the world. Or something, something. Fourth or fifth. Did not know that. For some reason, just didn't come across as. It's like almost the same size as the United States. But with forests. I mean, that thing's huge. But just somehow, like, I didn't realize how big that is. It's like the fourth or the fifth biggest country in the world. It's crazy. Okay, sorry, I'm distracted. Good. So I was asking, how does he know that? Well, it turns out it's probably because Google is looking at distance, current traffic, real-time information, right? I'm pretty sure someone has reported. So it's going to tell you that there is an accident, therefore there's an accident, but it doesn't tell you exactly why, right? But the accident can be broadcast through the radio system. It can be recorded by some application that runs on Android. It might be a geolocation stuff that runs on your phone. So collectively, the statistics is what tells optimizer the cost of a particular access method. So the statistics on the table, the statistics on the column, the statistics on the various object It is those statistics that helps the optimizer came up with these estimates. Therefore, it says, if you want to get there, this is the best route. And if you don't have a car, you should then try the air train, 42 minutes. And if you're dead set on walking, it takes an hour and 57 minutes. Now, strangely, get directions. Okay, so you notice driving takes 8 minutes. Bus takes 39 minutes. And the walking through the park, 4.3 minutes in an hour and 25 minutes. That's a pretty slow walker, isn't it? I'm pretty sure you can walk there faster. Or maybe you can't. Just maybe you go this way. Yeah, this is a really nice walk through the park. There's yeah, it's an hour and 30 minutes. But you know what? When it snows bad, you know when you walk, you will get there in an hour and 30 minutes. But if you take the bus, you're not sure if you'll actually get there. And if you drive a car, I just hope there's no some crazy things going on here, but you get the idea. All right, so statistics on the table and a column determines the cost of each access. And the cost eventually becomes what the optimizer use to decide what is the best access method. So here, I just ran a query. Now this is what we call the execution plan. And you see the execution plan says, actually, you know what? You have your SQL developer, right? So let's say you click on your SQL developer, you right click. Actually, forget right click. There is the little button right there that opens a SQL worksheet. This guy right here. I think we need to take a break soon. So if you select that guy right there, you'll get a query window. $193. So here, let's say we go ahead and write a query. That says select star. This is the HR connection. Okay, so here's your query. And you would like the optimizer to explain to you what is the plan we should use. So this is the button that says, tell me what you are going to do. Just like Google, but nothing has happened. I have not actually gone out and tried to get the answer. I just says, give me the idea. Tell me what to do. Okay, that's all. Tell me what would happen. tell me what the server process has to do in order to come up with the answer. It says, use the index. Which guy? Which index? This index. emp ID pk. Use that index and perform a unique scan. So that means as soon as you find that one value, stop. That value has to be unique. So once you find 193, don't search anymore. Everything on that index is unique. So find 193, return it, done. Now, what that is going to return from the index. By the way, when you look at the back of a book, a real book, like a technical book, ASP.NET Web Forms, learning how to program Java. In the back of the book, there's an index, right? That index gives you page number. That page number tells you where the content is. So an index, this index returns a row ID. A row ID is the absolute locator for a record. So think of the index as storing this value and which row ID is the record located. So notice if I do a select star from hr.employees, you can query row ID directly. That is absolutely the fastest way to read an entire row, because the row ID tells you which data file, which block, which row within that block where you find that record. So the execution plan on this kind of query is that simple. Set auto trace only means I only want to see the plan. I don't want to see the results. I don't need to see the data. So notice table access by row ID. That's the simplest query plan possible. You gave me a row ID, let me go there and find it, done. But most of the times we don't ask questions like that. We ask questions like this. I need employee 193, so you went to the index using this where clause to find the row ID, and then the row ID is then used to access the table to return the rest. Now, if I just want a row ID, and if I just want, let's say I just want a row ID. Notice I don't even need to go back to the table, because if you're just looking for which page, the question, the answer to your question is which page has the word Java, then you don't have to actually go to that page because the answer is the page number. So here I'm looking for the page number, row ID. Piece of cake, right? Cool. Let me know if that makes sense. That's explain plan. Tell me what your plan is. Auto trace. Oops. Okay, not enough permission. No worries. I'll use somebody else. Bam. Now the auto trace, on the other hand, actually travels according to the plan and record everything that happens. Oh, buffer is not pin count. Okay, consistent get from cache. CPU use call, cursor authentication DB time use, in queue releases one, in queue requests one. So this gives you what happened. Okay. So that's the difference between these two buttons right here. It tells you go ahead and do it and report back. So I'm going to get in the car. I'm going to start driving to JFK or LaGuardia, and I'm going to start writing each segment. How long did it take? How long did I have to wait? How much memory? How many logical read? How much memory did I consume? Okay, and so on and so forth. Okay, pretty cool. All right. Now, usually, when you're trying to get that information, you want to run it at least 2, 3 times to get a more accurate. Because the very first time you run, there's some overhead involved, but subsequent execution should stabilize. So logical read, number of bytes from cache. Okay. Request to and from client, session cursor cache hits. 2, session logical read. How many times do I have to sort? Sort rows. Why do I have to sort rows? Now, remember this $stat is for your overall stats. Okay. So if you do that, let's say, tell me what happened. All right, so this should give you a pretty good starting point. Cool. Session logical read for your session. Very cool. All right, folks, we need to take a break. We've been on this for a while. Let's take a quick break. And folks, in the meanwhile, while we are on break, if you think of any questions, please